Hello, it's Mr. Bush here, and today we're going to talk about three main topics for the STAR test. That's going to be the lunar cycle, tides, and weather maps. Let's go ahead and start with the lunar cycle. Alright, the lunar cycle is about 29 days long, and each moon phase in the cycle takes about 3.5 days to complete. Let's look at each moon phase. Alright, these are the 8 moon phases. Basically, it starts off the cycle with the new moon. The new moon is completely dark, and it's always between the sun and the earth. And basically 0% of it is lit up. The waxing crescent is basically a small sliver, like a crescent, like the name says. And you're going to have, for waxing, the light is always going to be on the right side. You always look at the right side. For the first quarter, same thing, except it only has 50% of the moon lit up. If you notice, the moon is basically growing or getting bigger in the waxing phase. And once again, the light is going to be on the right side. And with the waxing gibbous, it's going to be about 70 to 90%. It's almost a full moon. The light for waxing, once again, is on the right. And in about 3.5 days after your waxing gibbous, you get a full moon. Now, a full moon is going to be 100% lit up, and it's going to last for another 3.5 days. Then basically darkness starts to go across the moon. You also look at the right side. If you see darkness on the right, then it's going to be waning. And it slowly gets smaller, so it goes to a waning gibbous, which is about 90 to 70% of the moon is lit up. Then the last quarter, which has about 50% of it lit up, and the darkness is on the right. And then with the waning crescent, once again, darkness is on the right, and it's going to be about between 10 to 30% lit up. Alright, let's go ahead and look at this in basically how it would look in the actual space. Alright, this is basically a circular pattern with the moon cycles. The new moon always occurs between the sun and the earth. Basically, the moon is kind of like a mirror, and when it's between the sun and the earth, all the light gets reflected back to the sun, and all you see is darkness on the earth. Then, directly across from that, over here is going to be your full moon. Basically, once again, like a mirror, it reflects the light back to the earth. And then, basically, you can fill in the pieces in between. Those are the first two you want to get. The full moon is always on the opposite side of the earth, and the new moon is always between the earth and the sun. So let's go ahead and look at the other ones. Alright, directly after the new moon, you have the waxing crescent, then you have your first quarter, the waxing gibbous, and then you had your full moon, and then once it's gotten completely full, it starts to get darker again. And you have the darkness moving in on the right side. So you'd have a waning gibbous, a last quarter, and a waning crescent. Alright, let's go ahead and look at how we tell time through the lunar cycle. Now, once again, just going to repeat this. Every moon phase is going to be 3.5 days. So, when you're counting, like let's say you're going to start on our first quarter here. And I said, what moon phase would occur 7 days later? What you'd do is you'd count for each moon phase, you'd count 3.5. So you go 3.5, 7. So basically you go 3.5 to the waxing gibbous, and then 7 to the full moon. And the full moon will occur 7 days after our first quarter. All right, let's go ahead and try it one more time. All right, let's say the question asked, what moon phase will occur 11 days after a waxing gibbous. So the way you would find this is you'd count 3.5 days for each moon phase. You go 3.5 to the full moon, then 7 to the waning gibbous, add another 3.5, that would bring you up to 10.5 to the last quarter, and 11 is closer to 10.5 than it is 14, so you'd say you'd have the last quarter or a third quarter moon. Alright, let's go ahead and move on to tides. Tides are going to be when the ocean rises and falls. It usually occurs about 4 times every day. You'll have 2 high tides and you'll have 2 low tides. Basically, on a high tide, the water goes up. On a low tide, the water goes back down. So this picture over to the left, that occurred in basically 6 hours. The water all went from a high tide to a low tide. In the picture over to the right kind of shows how that works. You have an area where the water can rise up to, and then during the low tide it sinks back down to a lower area. So let's look at what causes this, and it's related back to our moon. Now, if you remember from Newton's laws, nothing really moves without an unbalanced force pulling on it. So what is causing the ocean to move? Well, it's going to be the gravity from the moon. Now, the closest force that you could actually observe on Earth to gravity is going to be magnetism. And very similar like magnetism, it pulls in a straight line. It pulls basically the water to the closest point to the moon. So let's think of basically the gravity pulling in this nice straight line from the moon. All the water is pulled towards that point. However, if you remember, our Earth is always spinning, so the point that's in a straight line with the moon is always changing. So as the Earth rotates, causing day and night, the point that's in a straight line with the moon is constantly changing. That point is going to have high tides. Basically, the water is being pulled over there. As you can see, basically you get like this bulge here with the high tides. However, what is causing our low tides? Well, think about this. The gravity is pulling the water towards it, but it does not create water. Therefore, the water that created the high tide had to come from somewhere, and that area is going to be our low tides. So basically, anything in an area with a straight line to the moon has high tide. The ones that are perpendicular are going to have low tides. And the Earth basically has, every area on Earth that is next to the ocean has 4 tides every day. 2 high tides, 2 low tides. So regardless of what moon phase it is, there are always 2 high tides and 2 low tides every single day. Now let's look at a special type of tide. It's going to be called a neap tide and a spring tide. Alright, a spring tide is basically just going to be a very large high tide and a very low tide. And they're caused by 2 different moons, a full moon and a new moon. And the reason why they cause these spring tides is they are in a straight line with the sun. When the sun and the moon are in a straight line, their gravities add together. Think of it like the unbalanced forces. When they're pushing in the same direction, they add together. That pulls a lot of the water, creating a very large high tide. And since a lot of the water went for that high tide, you have a very low tide. Alright, so we'll go ahead and look at a neap tide. A neap tide is basically when there's very little difference between a high tide and a low tide. Basically, there's not going to be a lot of change. There will be maybe a 2 or 3 foot difference between the high tide and the low tide. And they're caused by quarter moons. Basically, a quarter moon is when the gravity of the sun and the moon are going to work against each other. So what you have is the gravity from the moon is pulling in this straight line, but you also have a little bit of the gravity from the sun pulling back. So what happens is the sun is basically canceling out some of the moon's gravitational pull, which is why there's a smaller difference between, there's a very small difference between the high tide and the low tide. Alright, let's go ahead and move on to weather maps. Alright, let's go ahead and recap a little bit on weather. If y'all remember, the Earth's surface does not heat up evenly. Example, the water will heat up slower than, let's say, sand, or grass will heat up slower than sand or rock. This creates slight pressure differences, and it will start to create what we call convection currents. This is where the cold air sinks and the warm air rises, creating that giant circle, kind of like what you can see in boiling water if you put like little paper chips or stuff like that in. So if y'all look over here, basically as one area heats up quicker than the other, it creates a slight pressure difference. And that creates what we call our local winds. Basically, our winds are always created, I'm going to repeat this a couple times, because it's always created whenever the earth heats up unevenly. It can be caused by convection currents or pressure differences. Now let's go ahead and look at how we predict some of this using a weather map. There are four major types of weather fronts: warm fronts, cold fronts, stationary, and occluded fronts. A warm front, like the name says, is basically warm air moving in a large group. A cold front is basically cold air moving in a large mass. Now a stationary is whenever cold and warm air meets. However, neither of them are giving way, so it's kind of just sitting still. And an occluded front is when a cold front pushes a warm front along. Now the little bumps, basically a round bumps, indicate a warm front. Think of it like little half suns. And the direction of the shapes indicates the direction that front is going to be moving. Now, our cold front are like little triangles. Think of them as icicles. Once again, they point in the direction the front is going to be moving. Now, a stationary, if you notice, you have the bumps are on both sides. That indicates neither one of them is winning, so they're staying stationary. And in a occluded front, basically, as you can see, the cold front is pushing the warm front along. Let's go ahead and look at how this works on a map. Alright, if you look at this map, basically it indicates that there's a cold front moving in this direction. So what's going to happen in the forecast is whatever the temperature is over here during the cold front, like let's say it's 39 degrees, pretty soon that's going to move into this warmer area and the temperature is going to drop for the warmer area. And once the cold front gets there, it should go down to roughly about 39, 40 degrees. Alright, let's look at this on a map and then we'll be done. Alright, if you look over here, because it has a bunch of triangles, think of them as icicles. This means that a cold front is moving in this area, and it's basically everything's going to get colder in front of it. If you look over here, we have a warm front, and that basically means that everything in this area is going to get warmer. The same up here. Your stationary front, let's say like this part of it right here, right here is not moving, therefore it's not going to go anywhere as far as that area goes. And let's go ahead and look at our high pressure and our low pressure. So basically, high pressure means sunny. So any place that basically has high pressure, you're going to have typically sunny conditions. So anything in this area over here is going to be sunny. Now that does not mean warm. It just means that it's going to be sunny, stable weather conditions. Now, our low pressure is the exact opposite. It's often going to be stormy. So over here with our low pressure, often think of it as cloudy and stormy, unstable weather. So, high pressure is sunny, low pressure is cloudy. Our little triangles are cold fronts. Think of them as icicles. Our round ones are warm fronts, and they move in the direction of the little shapes. All right, hopefully this was helpful, and y'all have a great day.